So here is the first type of a non-homogeneous second order differential equation when it's equal to a constant. So the first thing we ought to do is to work out the complementary function. So we're going to say, well, that's going to be m squared, because we've got a d2y by dx squared, minus 5m, because we've got a 5 dy by dx, plus 6. And we're going to make this equal to 0. So we can factorize this to give me m minus 3 and m minus 2 respectively equals 0. So our roots are m equals 3 or m equals 2. So we can say our CF is that y equals to a times e to the power of 3x plus b times e to the power of 2x. Now notice that our equation is equal to a constant. So what we're going to do, according to our table here, that if our function is equal to a constant k, then our particular integral will be y equals to c. So we're going to write that down. So we're going to say that we're going to assume that our particular integral is y equals to a constant c. And so we can differentiate that to give me dy by dx equals 0, and we can say d2y by dx squared is also 0. And we're going to substitute these values back into our differential equation. So we're going to get 0 minus 5 times 0. So let's write that in for completeness. Plus 6 times whatever our y was for the particular integral, in our case c. So we're going to replace the y with a c, and that's going to be equal to the term or the value 3. So we're going to make that equal to 3. So that just gives me 6c is equal to 3. C is equal to 3 over 6. C is a half. So we can say our particular integral pi is y equals to a half. So therefore our general solution gs is the complementary function plus the particular integral. So in our case, therefore, y is a times e to the power 3x plus b times e to the power 2x plus a half. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So we're going to first set up the auxiliary equation, which is going to be the following here. It's going to be m squared plus 6m plus 5 equals to 0. And we're going to solve this quadratic equation. So that gives me m plus 5 and m plus 1 equals 0. So we can say that our roots are m equals to minus 5 or m equals to minus 1. So our complementary function is y equals to a times e to the power minus 5x plus b times e to the minus x. So that's our complementary function. So now our particular integral, because our differential equation is equal to a constant 10, we're going to assume that our pi y equals to c. We differentiate these, dy by dx equals 0, d2y by dx squared also equals 0. Substitute these into our equation. 0 plus 6 times 0 plus 5 times whatever the particular integral was equals to 10. So we get 0 plus 6 times 0 plus 5 times our particular integral, which is c, equals to 10. 5c equals 10. C equals to 2. So we could say our particular integral pi is y equals 2. So our general solution is y equals to the complementary function plus the pi. In our case, therefore, y is a times e to the minus 5x plus b times e to the minus x plus 2.